Starting off with your second part of topic number 5, further mechanics, we'll be discussing circular motion या motion in a circle भी इसको कहते हैं. इसमें this is a completely new chapter that is going to be taught in your A2. इसके अंदर हमारे पास centripetal acceleration, centripetal force, vectors, Newton's laws of motion, उसके बाद circular motion in a charged particle, different angles to radians करना, radians to degrees convert करना, centripetal force क्या होती है, when it is वेयर इज इट एक्टिंग एज वेल, और इन टर्म्स ऑफ आर्क लेंथ वगैरह जैसे आप मैथ्स में निकालते हो रेडियसेस, वो वाले कुछ कॉन्सेप्ट्स भी यूज हो सकते हैं एज वेल. सो स्टार्टिंग ऑफ विद द बेसिक्स ऑफ सर्कुलर मोशन, expressing angular displacement in radians and in degrees, and we are then going to convert between these units as well. सबसे पहले we are also going to talk about defining angular velocity, angular speed, centripetal acceleration, centripetal force, और different equations भी हमने इसी में डिराइव करनी है. प्रीवियसली आपको एक चीज़ पता है, आप मैथ्स की भी स्टूडेंट हो, कि एंगल्स कैन आल्सो बी मेजर्ड इन रेडियंस एज वेल एज इन डिग्रीज. तो हमारे पास कुछ कन्वर्जन्स हैं दैट यू नीड टू नो. कैन यू टेल मी कोई कन्वर्जन होती है, हाउ डू वी कन्वर्ट फ्रॉम रेडियंस टू डिग्रीज या फिर डिग्रीज टू रेडियंस? एनी आइडिया कैसे करते हैं?
180 में प्लस करते थे, डिवाइड में कुछ करते थे, कंफर्म नहीं।
पाई बाय 180, 180 बाय पाई. So for an object
हम्म,
moving in a circle, we often need to measure where it is around that circle. I sent you two PPTs yesterday. वो आपने दोनों पावर पॉइंट्स पढ़ ली थी?
जी
तो उसमें तो लिखा हुआ है, मतलब नहीं पढ़ी? For an object moving in a circle, we often need to measure
नहीं
where it
पढ़ी
is
में
around that
कंफ्यूज हो
circle.
जाता हूँ।
For
वो
example,
कन्वर्ट
to
करने
consider the relative positions of planets in their orbits at a particular time, we need to able to state where each one is. अगर आपने हर दफ़ा किसी एक ऑर्बिटल्स हैं, जैसे ऑर्बिट्स हैं, planets also ऑर्बिट अराउंड द सर्कल एज वेल. तो इफ़ यू वांट टू मेजर कि इस वक्त प्लैनेट कहाँ पे है इस ऑब्जेक्ट में, उसकी relative पोजीशन क्या है, कितनी देर में वो कहाँ पे पहुंच रहा है, यू हैव टू नो ईच ऑफ देयर पोजीशंस एज वेल. वो हम इन टर्म्स ऑफ एंगल्स ही बता सकते हैं, जैसे बेरिंग बताते हैं मैथ्स के अंदर, या एंगल्स दैट कैन मेजर इन डिग्रीज. दे आर यूज्ड एक्सटेंसिवली इन नेविगेशन एज वेल. जैसे बेरिंग आपने पढ़ा हुआ है, बेरिंग मैथ्स में डायरेक्शन बताने के लिए होता है एज वेल. प्लस वी कैन ऑल्सो यूज देम टू डिस्क्राइब द डिफरेंस बिटवीन मूविंग फ्रॉम वन स्टार्टिंग पॉइंट to two possible destinations as well. This is measuring angular displacement on the surface of the earth, and each degree is subdivided into 60 आर्क मिनट्स एज वेल. जैसे एक घड़ी है, घड़ी के अंदर भी कितने सेकंड्स होते हैं आपके पास? ठीक है, 60 सेकंड्स हैं एक घंटे में जी, 60 मिनट्स हैं एंड ऑल ऑफ दैट. तो हम एक डिग्री को डिवाइड कर देते हैं इन 60 आर्क मिनट्स या 60 आर्क सेकंड्स में. एक 60 आर्क मिनट जो है, एक आर्क मिनट जो है वो 60 आर्क सेकंड्स में भी डिवाइड हो सकता है. When we are measuring rotation, we often use the alternative unit to measure the angle, जिसको हम कहते हैं radian. The circle itself defines this. Imagine an object moves around part of the circumference of a circle. The angle through which it moves is measured in radians. तो हम डिग्रीज के बजाय we are going to prefer the unit radians when we are doing the calculations in physics as well, which is defined as the distance it travels divided by its distance from the center of the circle. If the radius of the circle were 1 meter, then the distance the object travels around a circumference would also be equal to the angle swept out in radians. तो सबसे पहला जो फॉर्मूला हमारे पास आना है वो ये है कि अगर आपने एंगल निकालने रेडियंस के अंदर, आप आर्क लेंथ को डिवाइड कर सकते हो बाय द रेडियस एंड यू विल गेट योर एंगल्स इन रेडियंस. अगर आपने यही डिस्प्लेसमेंट को अगर आप यहाँ पे सब्जेक्ट बनाते हो आर्क लेंथ, तो वो क्या हो जाएगा? आर थीटा. तो यही दो इक्वेशंस हैं दैट यू शुड, इनको नोट डाउन कर लें बेशक, दैट विल बी यूज्ड इन फर्दर टॉपिक्स एज वेल. दिस इज नोन एज, ये है वो डिस्प्लेसमेंट, इसको हम कह सकते हैं एंगुलर डिस्प्लेसमेंट. दिस इज ऑल्सो नोन एज योर एंगुलर डिस्प्लेसमेंट, या फिर हम इसको आर्क लेंथ कह रहे हैं मैथ्स में. इसको आर्क लेंथ कहते हैं, दैट वी आर रिप्रेजेंटिंग विद द सिंबल एस. ये आपको ऑलरेडी पता है ये क्या चीज़ है जी, ये पूरा आपके पास रेडियस है, और ये आपके पास डिग्रीज है, रेडियंस है. तो असल डिस्प्लेसमेंट जो एंगुलर डिस्प्लेसमेंट है वो तो हमारे पास कहाँ से आएगी? रेडियन से आएगी. और इस एंगुलर डिस्प्लेसमेंट को यू कैन ऑल्सो कैलकुलेट बाय 2 पाई आर ओवर आर, क्योंकि 2 पाई आर बेसिकली सरकमफेरेंस है ना. अगर आपने कहीं से आर्क लेंथ निकालनी है, आर्क लेंथ इज ऑल्सो वॉट? फॉर अ कंप्लीट सर्कल द आर्क लेंथ इज बेसिकली सरकमफेरेंस. ठीक है, सरकमफेरेंस ही पूरी आर्क लेंथ होगी ना एक तरह से. एंड सरकमफेरेंस क्या होता है? 2 पाई आर. तो यही फॉर्मूला अगर हम लगाते हैं, एंगुलर डिस्प्लेसमेंट इज इक्वल टू एस ओवर आर, एस की जगह अगर हम 2 पाई आर लिखते हैं, सो इट बिकम्स व्हाट, 2 पाई आर ओवर आर, और वो आर आर कैंसल आउट होके बन जाएगा 2 पाई रेडियन। मतलब कि ये बात सही है दैट वन कंप्लीट सर्कल, मतलब कि 360 डिग्रीज इज इक्वल टू व्हाट, 2 पाई रेडियंस। इस तरह से तो फिर जो 180 डिग्री होगा, 180 डिग्री इज गोइंग टू बी इक्वल टू पाई रेडियंस, देन हाफ ऑफ 180 डिग्रीज इज गोइंग टू बी योर पाई/2 रेडियन, मतलब कि 90 डिग्री इज गोइंग टू बी योर पाई/2 रेडियंस, देन 45 डिग्रीज वुड बी योर पाई/4 रेडियंस। 270 डिग्रीज की अगर बात करें, 270 डिग्रीज इज व्हाट, 3/4 ऑफ अ सर्कल, so it's like 3 pi/2, 1.5 radians, 3 pi/2 radians हो जाएगा is equal to 270 as well. You can see all of the different common conversions जो आ सकती हैं, like I have discussed that pi radians means 180, 2 pi radians means 360, 3 pi/2 means 270, pi/2 means 90. So this is we call it as the angular displacement as well. Displacement, and so it is going to be a vector measurement. Angular displacement is the vector measurement of the angle through which something has moved. The standard convention is that anti-clockwise rotation is a positive number and a clockwise rotation is a negative number. Jahan jahan bhi we are going to see a clockwise rotation, that is all going to be a positive number. And whenever you observe an anti-clockwise rotation, that will be written in negative. For example, acceleration जो हम देखते थे, whenever something is moving up or to the right, it's positive. Whenever something is moving downwards or leftwards, it is also always taken as negative. What is angular velocity then? An object moving in a circle sweeps out a particular angle in a particular time, depending upon how fast it is moving. The rate at which the angular displacement changes is known as the angular velocity. So, angular velocity is measured in radians per second, and it is mathematically defined by omega. This symbol is known as what? Omega. Omega means angular velocity. Angular velocity is equal to what? What is velocity? Velocity is equal to distance over time या फिर displacement over time, right? So if we are talking about angular velocity, then what is the displacement of angular velocity? The change in angle? Because we are not talking about straight line motion, we are talking about a circular motion. In a circular motion, angular velocity will be equal to, we can switch the displacement, and what can we write in place of distance? Delta theta, change in angle divided by the time. And this is the answer that you get, that omega is equal to delta theta divided by t. So if the object completes a full circle, if they have a scenario where the object is converting the whole motion, is completing a whole motion in one complete circle, then in place of delta theta, can I write 2 pi 2 pi radians divided by t? And if we want to find t, we can also do 2 pi divided by omega as well. So this is the same thing as velocity is equal to displacement over time. But over here, in terms of circular motion, it's not a straight line motion. We are talking about a circular motion. So in a circular motion, the distance is the angle basically. An angle will be measured in radians. We also know that frequency is equal to 1 over t, right? So if we look at this, angular velocity is equal to 2 pi by t, right? We also know that frequency is equal to 1 over t. So can I also write omega is equal to 2 pi f? So omega can also be found by this formula, or omega का एक और formula is 2 pi f. Instead of thinking about the angular movement, let us consider the actual velocity of the moving object as well. That is also sometimes called as instantaneous velocity. Instantaneous velocity is the velocity at a particular instant, at a particular time, at a particular position. And we know that v is equal to s over t. And from the definition of the angles in radians, which was what? Theta is equal to s over r. S was the arc length, right? And if we rearrange the equation, s is equal to r theta. Other say we can also define that v is equal to what? S over t. Velocity is equal to displacement over time. In place of s, can I write r theta? R theta divided by time is also equal to what? Velocity, right? And in place of theta over t, if I replace, अभी इसको ध्यान से देखें, look at this. In place of theta over t, can I write omega, right? And if I can write omega, then the formula becomes of v is equal to r theta by t की जगह we have written omega, because we just discussed that omega is what? theta by t, right? Now the formula that is we have is v is equal to r omega. And this is a very important formula. In figure D, we can see a geostationary satellite. Geostationary satellites you'll be studying in the gravitation chapter as well, orbiting the Earth. What is its angular velocity? To find the angular velocity, remember that it completes an orbit at the same rate as the Earth revolves, which is a one complete circle, right? जो कि 24 hours का होता है. So we can find the angular velocity. The formula is what? 2 pi by t. 2 pi divided by what's the time? 24 into 16 to 60. The answer is 2 pi by 86 400. So what is the velocity of the geostationary satellite? 7.27 into 10 to the power minus 5. What are the units of angular velocity? Angular velocity is equal to theta over time. Theta is in radians and time is in seconds. So it's radians per second, radian s minus 1. Now, if the radius of the Earth is 6400 kilometer and it is in the orbit 35600 kilometer above the Earth's surface. Okay, so we have the radius as well and we are given the height as well from the surface, right? So if we combine the radius and the height, can we have the total distance over here? This is now what? The total distance that we can call as r. So now we can also find v. V is equal to what? R omega. What is the radius? The radius of the earth plus the height. The radius of the earth plus the height, because the satellite is over here. This is the satellite, right? So this whole distance is going to be the orbital radius. हमने यहाँ पे orbital radius discuss करना है, not the Earth's radius. So इस radius को, total radius को we have to multiply by the omega, because the formula is v is equal to r omega. So r multiplied by the omega value that we found, which was 7.27 into 10 to the power minus 5. You add up both the radius and the height and into 10 to the power 3 क्योंकि because it is kilometer. Multiply it with your omega and you have your velocity over here. Then we have another concept known as centripetal acceleration. If velocity is a vector, remember acceleration is also a vector. And velocity being a vector, it is correctly described by both its magnitude and direction. And acceleration can change either of these or both. For example, an object moving in a circle may travel at a constant speed at a constant angular velocity, but the direction it is moving in must also constantly change. This means it is constantly accelerating, and as this acceleration represents the change in direction around the circle, it is called as the centripetal acceleration. Because what is happening in a circular motion? At every point, the velocity is changing as well. And if every point in a circle the velocity is changing, then that means acceleration is also changing, because acceleration is defined as the rate of change of velocity. If an object is over here, उसकी velocity over here है. अगर एक object ऐसे है तो उसकी velocity इस वक्त यहाँ है. And if an object is over there, its velocity over there. It's always along the tangent of the circle. So at the arbitrary positions of rotating object A and the time t later b, consider the components of the object's velocity. Now, if this is the circular motion, this is the object acting in that direction. This tangent is going to have what? A horizontal component as well and a vertical component as well. And we also know that the vertical component is equal to v is equal to sine theta, because it's in front of the angle, and the horizontal component is equal to v cos theta. As A and B are equal distances above and below point C, the vertical velocity over here is going to be v cos theta. So cos theta, let me check. Okay, if this is the tangent, right? This is the tangent, this is the vertical velocity, and this is the horizontal velocity. And horizontal velocity is beside the angle. So yes, in this case, remember one thing. In front of in front of the angle, we always have sine. Remember, yeah, I have told you this rule before as well. Vertical is not always sine theta, ठीक है? अपने एंगल को देखना. If एंगल के सामने कौन सा वाला कंपोनेंट है, vertical acceleration will be 0, because cos 90 is also 0, and horizontally the magnitude of the velocity will be equal at both of the points but in opposite directions as well. तो यहाँ पे horizontal velocity over here is v sin theta, और अगर आप दूसरी एंटी क्लॉकवाइज डायरेक्शन में देखोगे then it is going to be minus v sin theta over here. So what is the formula of acceleration? Acceleration is equal to change in velocity over time. So in place of velocity, can we write 2v sin theta? because the acceleration is just the horizontal acceleration calculated as change in velocity divided by time. And from the definition, now you're wondering why is this written 2? Because we have two times. हमारे पास we are combining the horizontal and the vertical component as well, the clockwise as well and the anti-clockwise as well, because we have to find both of them at A as well and at B as well. Again, you can directly memorize this as well, that A is equal to 2v sine theta divided by t. And from the definition of angular velocity above, we know that v is equal to s over t theta. In place of s, I wrote r theta. Why? Because s is equal to r theta, right? ये सारी इक्वेशन साथ साथ लिखते जाए, otherwise you're going to forget it. Okay, s is equal to r theta, so that is why in place of s over t I have written r theta over t. And if we want to make time the subject, it will become what? R theta divided by v. And the angle moved over here, as we were given in the question as well, it was 2, right? We also multiplied 2 over here. हमने v sin theta के साथ भी 2 मल्टीप्लाई किया क्योंकि this angle was twice. We have this theta as well, we have this theta as well, so it's always going to be 2. So r2 theta divided by v. और अगर हम इस पूरे को एक्सेलरेशन के अंदर पुट करें, in acceleration what was the formula? Delta v over t. So in place of t, can we write this whole thing? So when we are going to write this whole thing, ये वाला पूरा as a denominator आ जाएगा, it's going to rearrange itself and it's going to become this type of equation over here. So from there we have derived one very important thing which you have to note down, the two equations, which are A is centripetal acceleration is equal to v square over r, and centripetal acceleration is equal to r omega square. These are the two important equations that you have to remember for centripetal acceleration. The centripetal acceleration in this case is just the horizontal acceleration, as we also considered the object in a position along the horizontal radius following a similar derivation at any point around a circle will always have identical components of velocity that are perpendicular to the radius on either side of the point being considered. What is the centripetal acceleration of the satellite? So we can, what is the data given to us? We had the v square as well, we calculated it, and we had the r as well. Remember, the radius of the earth plus the height at which the satellite was, and it was in kilometers. That's how we can find acceleration. But remember, we also had omega in the above question, right? So we can also use the second equation of acceleration. That will also give us the same answer. You can use v square over r as well, you can use r omega square as well, but this is the very important two formulas that we have done in today's lecture: centripetal acceleration. Other formulas इसके अलावा, if I can write it down over here for you, we have v is equal to r omega. You can note it down. Then we have s is equal to r30. Then we have omega is equal to 2 pi by t. This can also be rearranged as t is equal to 2 pi divided by the angular velocity, which is omega. Then we have done a is equal to v square over r, or you can write it as v is equal to r omega square as well. ठीक है, इसके अलावा you can also write theta is equal to s over r, which is the same thing. ये वाली है, this is the same rearranged equation as well. Radian is the unit of angle measurement, because we can say that 1 radian is equivalent to 57.3 degrees. Angular displacement, on the other hand, is the vector measurement of the angle through which something has moved. Angular velocity is at the rate at which the angular displacement changes. For example, radian per second, हमने इसका unit अभी देखा था, because it is theta divided by the time, right? So then we had centripetal acceleration, because if the velocity is changing, it's a vector, and if it's along the tangent of the circular motion, velocity changes. If velocity changes, centripetal acceleration also changes, which is always acting towards the center of a circle that corresponds to the changes in direction to maintain an object's motion around that circle. And that is all for your centripetal acceleration. Let me show you one thing as well. Is everything clear till here? Any problems? ये वाला clear हो गया? Let me give you a quick overview from here as well. Right.
Natural and more flexible than type A. He said he's voice pilled, and I can send in A level physics.
Okay, let's get started and not lose any time. The first thing that we need to be looking at is the radian as a measure of an angle. Now remember, if we wanted to convert from degrees to radians, what we need to do is multiply by pi and divide by 180 degrees. And if we're going the other way around, if we're going from radians to degrees, we need to multiply by 180 degrees and we need to divide by pi. A couple of useful ones just to remember. So one full oscillation, one full circle is 360 degrees, which is equal to 2 pi radians. Additionally, 180 degrees is half of that, that's pi, and 90 degrees is half of that, that is pi over 2 radians. Okay, next thing we need to remember are the time period, which is the time it takes to complete one full circle. Essentially, the time it takes to complete one full orbit for an object which is moving in a circular motion. The time period is 1 over the frequency, and the frequency is 1 over the time period. Now additionally, we can find the time period or the velocity of an object that is moving in a circle, and let's say that the radius of this circle is r. Now if that's the case, the velocity is given by the circumference, which is 2 pi r divided by the time period t. Okay, next one, omega, our angular velocity. Now remember, our angular velocity tells us what angular displacement we are covering in a given time period. So it's the angular equivalent of normal linear velocity, and the equations that we can use to find them are that omega is 2 pi over the time period, and because the time period is 1 over the frequency, we can also say that omega is equal to 2 pi f. Additionally, linear velocity and angular velocity are related by this equation, that v is equal to omega times r. So once again, the angular velocity omega, that tells us how much angular displacement, let's say delta theta, we cover in a second of rotation, whereas the linear velocity tells us the tangential velocity at a given point and what that magnitude is. They're related by v is equal to omega r. If we substitute one of those formulas for omega, for example 2 pi r over t, if our circle is of radius r, we come back to our normal equation that the linear velocity is equal to the circumference divided by the time period. We will also need to remember how to convert from RPM, which is revolutions per minute, to radians per second for our units for our angular velocity. The conversion factor, if we're going from RPM to radians per second, is multiplying by 2 pi and then dividing by 60. For instance, if I had something which was spinning at 200 revolutions per minute, so RPM, so that means that it does 200 complete cycles in 1 minute. So the actual distance, the actual angular displacement that it's going to cover is going to be 200 full circles, which is 200 times 2 pi, and the amount of seconds in 1 minute is 60, so because it's per minute, it'll be per 60.
This is your brain when you're struggling to focus, and this is your brain when you're in the zone.
Seconds, and if we put that into a calculator, we get about 20.9, call that 21 radians per second. Okay, so let's have a look at centripetal forces next. Now, what is a centripetal force? So that's a net force which causes the object to move in a circular path, and that force has two really important features. Number one, it is always directed towards the center, and number two, it is perpendicular to the linear velocity of that object. Common examples of those forces are, for example, the tension. If you have something which is being rotated in a circle, it could also be the gravitational force, it could be the frictional force, etc. The formula for it is given by mv squared divided by r. Now, from that equation, we can entail that there is a centripetal acceleration which is towards the center of rotation, and that centripetal acceleration is given by the formula of v squared divided by r. Okay, next one. Now, in circular motion, the linear velocity changes, however, the linear speed is constant. How can this be? Remember, you can have acceleration at constant speed because velocity is a vector quantity and only the magnitude, i.e. the speed, remains the same, however, the direction is constantly changing. So the centripetal acceleration changes the direction of motion only. Now, this next question is really important. That's why I've put this in red. Why does the speed of an object in circular motion not change? Now, the reason for that is because the net force is directed perpendicular to the direction of motion, i.e. the velocity. Now, this means that there is no work done by this force and hence there is no change in the speed. Remember, work done in general is equal to the force times the displacement times the angle between them. So it's fx cos theta, and cos of 90 degrees is equal to 0, which means that the work done will be 0 if the force F and the displacement x are perpendicular to each other. Now, because V is equal to omega r, we can rewrite the following two equations, one for the centripetal force and one for the acceleration, as the following. F is going to equal m omega r squared divided by r, which is going to give us m omega squared r squared divided by r. We can cancel those out, which is going to give us m omega squared times r. Similarly, for the acceleration, this is exactly the same equation, just without the mass in front of it. This is going to equal to omega squared times r. Let's have a look.
And that is all for this lecture. In the next lecture हम इस सेंटीपीटल फोर्स को डिटेल से डिस्कस करेंगे, लेकिन अभी के लिए सेंटीपीटल एक्सलेशन तक इट्स completely fine.